Assalamualaikum and greetings. My name is Farez Amsyar bin Zulkifli. My metric number is B0518810136, and today I will present about my bachelor degree project, which the title is Experimental Study of Milling Process Using Solid Lubricant. First of all, I want to thank Professor Madya Dr. Liew for supervising me throughout this entire semester. Overall, this presentation will cover about the introduction, background of the study, problem statement, objective, scopes, literature review, and methodology. First, the project revolves around the machining of milling process. Milling process is known due to its superior metal removal rate compared to other machining process. And even though it has a good material removal rate, the process still provides good accuracy as well as surface finish of the workpiece. As milling process is a conventional process which require a physical cutting tool, the contact of rotating cutting tool and workpiece during the cutting process will result in a friction, which then leads to heat generation. So, as stated by Gopalakrishna et al. 2014, friction affects the machining in negative ways on the energy consumption, temperatures, cutting forces, cutting tool life, and machine surface quality. Hence, this is where lubrication is applied at the contact point of cutting tool and workpiece during the cutting process. Sloman stated that application of lubricant results in increase of machining results of dimension accuracy, good surface finish, as well as extending the cutting tool life. Cutting tool is important in machining because a bad condition of cutting tool will result in a rougher surface of the workpiece according to Krishna and around 2008. Fast forward, recent technology has seen the use of solid lubricant in industry, especially aerospace industry, which require a very precise and less tolerance of machine product. So, solid lubricant usually used as a typical composed of a solid, a binder, or as an additive of powder mixed with a base cutting fluid such as oil or water, according to Butt et al. In 2030. On to the next one, the problem statement. As mentioned before, friction is a major problem in machining as it causes to increase the temperature of the cutting tool and the workpiece itself. The increase in uncontrolled temperature will result in dimensional inaccuracy of machine surface, poor surface finish, shorter cutting tool life due to wear and deformation, tool failure or breakage, increase of cutting force, and increase of tool wear. So, the objective of the study is to investigate the surface roughness, tool wear, and thrust force during the milling of mild steel by using molybdenum disulfide or MOS2 as a solid lubricant. The second objective is to determine the optimum parameters for milling of mild steel by using a design of experiment of Taguchi method. So, this study consists of 4 research scopes, which the first one is material, machine, parameter, and machining response. For the material, the workpiece that I will use is the mild steel plate. Meanwhile, the powder is MOS2 and the base fluid is palm oil. The machine that I will use is a CNC milling machine provided by the University Technical Malaysia Melaka, and the parameter of the study is the cutting speed, feed rate, and cutting condition. The machining response of the study is surface roughness, tool wear, and thrust force. For the literature review, I select 6 previous studies that are related to the title and parameters of the study. To summarize, study by Zailani et al. 2011 and Kilichai and Ubetan in 2016 found that solid lubricant improved the surface roughness, thrust force, and tool wear. Meanwhile, in another study of Nalban et al. In 2021, Paturi et al. In 2016, and Marquez et al. In 2015, found that MKL condition improved the surface roughness, tool temperature, cutting force, and tool wear. And for Agarwal and Agarwal study in 2021, found that increase of cutting speed and also feed rate increased the flank wear of the cutting tool. So, based on these studies, my research gap according to my current degree of knowledge, I found that there is no study on effect of MQL and cutting speed on MOS2 mixed with the palm oil. So for the methodology, this is my flowchart. The start, lubricant preparation, cutting tool and workpiece preparation, define parameter for experiment, measurement apparatus configuration, milling process, collect and record data, data analysis, and result and discussion. So for lubricant preparation, the mixture of the lubricant that I will use is MOS2 mixed with palm oil. The mix will be used using the Labsonic ultrasonic homogenizer type P series in total of 35 minutes with 50% of amplitude and 0.5 of interval. The particle size of the MOS2 that I will use is 90 nanometer with the mix concentration of 20 weight%. For the cutting tool and workpiece preparation, the workpiece that I will use is a multi-plate with the dimension of 100 mm of length, 60 mm of width, and 20 mm of thickness. And the cutting tool is a SEC wave radius mill RSF by Sumitomo for the body cutter and SCM 200 grade Sumitomo milling cutter for the insert. For the defined parameter for experiment, I will use the analysis statistical, the DOE, Taguchi method by Minitech software. The reason I choose Taguchi method is because it consists of less runs with only 9 runs. And to input in the software, there is 3 parameters and 3 levels, which the parameters are cutting speed, feed rate, and cutting condition. And while the level are level 1, level 2, level 3, as you can see, and the cutting condition are dry, MQL, and SL MQL, which stand for solid lubricant minimum quantity lubrication. And for the measurement and apparatus configuration, the purpose of this is to get a more accurate result and less probability of error. The measurement apparatus is to calibrate the equipment and configure the equipment within an acceptable range. Then the milling process. The milling process that I will do in next semester is according to this experimental condition, where you can see the depth of cut is constant at 0.5 mm and cutting length also is constant at 80 mm per minute. And the flow rate, I will use 150 milliliter per hour with the air pressure of 8 bar. To collect and record the data, there is 3 equipment that will be used, which is the surface roughness tester, dynamometer, and scanning electron microscope or SEM. For the surface roughness, there will be 3 samples and 3 measurements I will do to get a more validate and accurate data, where I will calculate the average data of it. And for the thrust force, the dynamometer will be installed on the machine directly, and the dynamometer will measure the cutting thrust force in real time. For the toolware, it will be based on the standard ISO 8688-2, where the 0.3 mm average blank wear all over the tip. For the data analysis, the data taken will be analyzed. I will analyze all the data, and then for the result discussion, the data from the experiment will then be discussed. That I will discuss this in next semester. So, lastly, my expected outcome is the presence of solid lubricant will result in best machining response of lower surface roughness, thrust force, and tool wear, and optimum parameters to reduce the surface roughness, thrust force, and tool wear could be obtained. And that's all for me. Thank you. Thank you to the panel. Thank you to my supervisor. Thank you.